Welcome back to TinkerCAD. So, continuing on sensors and actuators. Okay, so on this right side, the clicker starters. Okay, so we just follow these guides: breadboard, link, samples, fade button, okay, analog input or digital serial read serial or analog read serial. Okay, so this time we're gonna include LCD. Okay, okay. So there we go. We have the LCD. Okay, so this green one is the 2 by 16. Okay, 2 by 16 LCD or liquid crystal display. Okay, so in terms of connections, okay, you can also refer it to the code. Okay, here. So these are the different connections of the circuit. Okay, so just simply follow and connect, or you could also use this Circuito app, Circuito IO. Okay, Circuito IO. Okay, when you type here, search for the component and say LCD. LCD. Okay, so you have here different types of L- LCD. For advanced users, you can use this I2C. No? LCD 16 by 2 I2C using I2C connection. Okay, so what you're going to do is you're going to add. Okay, then it will automatically show you connection. Okay, so what's nice about this application is it will show you how it's going to be connected. Okay, okay, so as well as can also view the code here, can download. Okay, you can download the code. It's in here. Okay, going back to the design. Okay, so you can also remove this one, right clicking. Okay, then perhaps you can add a typical 2 16 by 2 LCD. Okay, so there you go. So at least in this uh, presentation, it's using a typical picture or real picture of a typical potentiometer. Okay, so but then again, in this circuit that IO doesn't have any simulation. So we're gonna go back uh, here in our TinkerCAD. Okay, so moving on, let's try to simulate first. Okay, so hello world. The zero here is actually current time. Okay, but anyway, this potentiometer will also use for uh, the controlling the brightness of the LCD. Okay, so we're gonna add. Okay, so this time we're gonna add a sensor. That is very common. what is known as the LDR, the light dependency resistor. Or in this case, there are three photosensors: the photoresistor, photodiode, and the ambient light sensor. Okay, but anyway, we're gonna use this LDR. Okay, or also known as the photoresistor. Okay, okay. So what is this LDR, light dependent resistor or photoresistor? So it's going to use a multimeter. So search for a multimeter and let's try to test its resistance. So, okay, let's connect it directly. So just like any resistor, doesn't have polarity because it's only generating resistance. Okay, so we're gonna focus on this area. Okay, so should be oh, using the resistance or the ohmmeter. Okay, so let's try to start simulation, then try to okay. So you notice that the LDR or the photoresistor has 180 kilo ohms. Okay, so you notice there is a slider here. You can slide it from the darkest to the brightest light because it's a photosensor, so it requires light. Okay, this is the darkness, no, the dark. What if I'm going to click and slide, click, hold, and drag this portion? Okay, so the more light that is exposed on the surface of this photoresistor or LDR, the resistance becomes less. Siguro it's around, yeah, it's 500 ohms. Okay, some could be lower than 500 ohms. Okay, but if it is in the dark area, it's exposed in the dark area, could go as high as this resistance, 180 kilo ohms. Okay, so we're gonna apply this, okay, in the analog input, okay, for sensing lights. So in order to use this, you need similar to a potentiometer. Okay, a potentiometer is a voltage divider resistor, with variable resistance that can vary the resistance. But this time, we're gonna add a resistor just to create a voltage division. Okay, so let us say we're gonna pick this typical, typical 1 kilo ohm. Okay, we're gonna connect it in series, okay, and connect it to our, let's say, in analog 0 pin. Okay, so it's a green signal. No, this is incorrect. This must be connected to the ground rather. So let's connect this to the ground. Okay, let's try to connect this side. There's a ground here. Okay, it must be black. Okay, then this terminal. Okay, so this terminal must be connected to the AO. Okay, analog 0 input for the analog reading. Okay, so we're gonna apply 5 volts here. So there will be a voltage division in this terminal, 5 volts. And do not forget uh, to label this color red. Okay, so there we go. So the voltage division between the 1 kilo ohm and the photoresistor or the LDR, okay, at the center will be the voltage that's going to measure across the photoresistor or LDR. Okay, so let's go back to, by anyway, let's try also to monitor the voltage, this one, okay, particularly at this junction. Then of course, with respect to the ground, okay, so it must be black. Okay, so let's try to play without reprogramming. Oh, sorry, it must be changed to voltage. Okay. So you notice that the voltage here is almost 5 volts, which means that the resistance of the photoresistor LDR is very much greater as compared to 1 kilo ohms. So you're in fact 180 kilo ohms. Okay, however, if you're gonna apply light, no, so this will, the voltage goes down to as small as around less than 1.7, okay, more or less. Okay, so let's go back to the maximum. Okay, okay, so let's go now to the code. This time we're gonna apply, okay, we're gonna apply the LCD, no, and displaying the voltage across the AO. Okay, so we're gonna add first, okay, we're gonna add a variable, ano, here in the setup. Okay, so we're gonna add pin mode. Okay, so A0, A0 has the analog input, okay, or simply input. Then in the void loop, we can also add a variable. Let's say this time we're gonna use float, no, floating point. Let's say volt. Now what's the voltage? Okay, so we're gonna read first the value of the port AO. So volt now is equal to analog read, okay, and this time it's AO, okay. Then in here, this time that the display is what's the time in milliseconds. So this time we're gonna, okay. So might as well include the formula, okay, formula for the converting it to voltage. So the maximum value here for analog read is 1023. So you're going to multiply it by a factor uh, 5 volts. We can apply point 0 because it's division by floating point. Because if division by integer, it becomes 0. Okay, 1023.0. Okay, so to make it sure that it will yield uh, floating point. So take note that the analog read has a maximum value of 1023. So 1023 divided by 1023, okay, is equal to 1. So therefore, the maximum voltage becomes 5 volts. Okay, in this part, we're going to remove this part and we're gonna display volt. Okay, so let's check if this is correct. Okay, the start simulation. Okay, so you notice that the multimeter or the voltmeter has the same output in our LCD screen, except with this hello world. Okay, so you can also edit that one if you like. That is found here in the setup. Okay, so you can add voltage, no? Or stop it first, then change it to voltage, no? Voltage at perhaps at the LDR or potentiometer. Okay, so let's try the start simulation again. You can see. Okay, so take note. It's now displaying 4.97. So this is the voltage at LDR. Okay, or we can also include here serial. You want serial dot begin. Okay, for the serial monitoring or serial communication. So it's starting. We're using the, the serial baud rate of 9600 bits per second, if I'm not mistaken. Then in here, we're going to display at the same time. Okay, serial, the print line, new line, the value of code. Okay, so I hope this is correct. Okay, so I'm going to click this serial monitor. Okay, let's check if it is also displaying the voltage. Okay, there you go. Okay, so you can use all of this technique, no? Particularly the serial monitor, okay, for the calibration of this LDR. Okay, so we're done with our sensor. This time we're gonna add actuator. Okay, so our actuator will be a relay, no, with the lamp. Okay, so I've already prepared the circuit. Okay, so this is our circuit. No, we have here the function generator acting as the 220 volts AC, and we discussed already the relay. Okay, of course the transistor is going to control the relay. So the lamp is connected to the normally open. Okay, so normally open of the relay connection. Then this one, the 220 volts, is connected to the common contact. Okay, so the idea here is if the if there is natural lighting exposed in the surface of the LDR, then the artificial lighting such as the bulb will not light. Okay, so that's the idea. Okay, so let's try to simulate first. Okay, so let's check it here first. So the idea is if the voltage is greater than, let us say 3, yeah, 3.0 or 3.1, it means that it's becoming darker. Okay, then you'll have here digital write for the relay, no, particularly the pin mode A5 where the relay is connected, the transistor of the relay is connected. Then else digital write A5 it turns off the light. Okay, so let's start to simulate. By the way, we need to change this voltage and LDR. Okay, start simulation. Okay, it's stated here that if the voltage is greater than 3.1, so which means it's dark. Okay, it's dark. It's dark. So the artificial lighting, which is the bulb, which is running at 60 hertz, that's why it's blinking, and our simulation is a little bit slower. Okay, so there is a need for the artificial lighting. However, if you're going to expose the surface of the LDR, okay, much more to the light, so you notice that the bulb now is turned off. Okay, so take note, we need to add 5 because we connected the transistor, base of the transistor to A5. Okay, and the formula, do not forget, no, this is the formula. Okay, and what we learn in FL control structure, okay, or just measuring the voltage. Okay, so I hope that you will appreciate now the usual function of the application, no? Application rather of a light dependent resistor. Okay, so bye bye.